Hello friends, and welcome to a new session with edupediaworld.com, your favorite portal for online education. Continuing our discussion with the measures of dispersion, today we shall take up the most important and the most widely used measures of dispersion. Yes, you got it right. It's the standard deviation. To recall, we had already seen the first three measures of dispersion, starting with the range, which was the difference between the maximum and the minimum value. Range, although was easy to calculate, but had several limitations, such as it was not based on all the data. It was calculated only by taking the last and the first value, the extreme values, and it was affected by the fluctuations of data. And further, it was not capable of mathematical treatment. Moving on, we took interquartile and interpercentile range, which were based on certain quartile and percentile values instead of the extreme values. But again, these were not based on all the data, and they were not capable of further mathematical treatment. Moving on, we took mean deviation. Now this was the deviation based on any one of the central tendency values, where we took the deviation from either arithmetic mean, median, or mode. This was not standardized, as we had to take any one of the central tendency values. Therefore we moved on, and now today we shall take up the standard deviation along with the variance. Now if you recall, in mean deviation, when we took the deviation from any of the central values, the observations falling below the central tendency value used to give a negative deviation. Now to take care of this negative sign, what we did was we just took the absolute values. If we had taken the negative sign as it is, the positive and the negative deviations would cancel out each other, and we will get 0 as the deviation. Therefore, we used to simply ignore the negative sign by taking the absolute value or the mod. Now the practice of ignoring minus sign of the deviation is very inconvenient, and it makes the formula unsuitable for further mathematical treatment. In order to escape this problem, what we do now is that we take the arithmetic mean of the square of the deviations from the actual mean of the data, and the positive square root of these are simply termed as standard deviation. So let's understand this before going any further. When we have a set of data, we take the central tendency value. In the case of standard deviation, we take the arithmetic mean, and then we find the deviation from this mean to all the individual observations. When we take it on the higher side, we get positive values, and when we take it on the lower side, the deviations would be negative. That is, we have the deviation, the individual values xi minus x bar, which could be positive or negative. Previously, to eliminate the negative sign, we simply used to take the absolute value of this. But now what we would do is we would square it, and we know that squaring any number, the result would be positive. Let's take an example and understand. Let's say that our central tendency value here is 15, and one of the observations on the lower side is, say, 8. Now when we take the deviation, it would be 8 minus 15, which would be minus 7. Now if we take the mod of this, we will get 7, the positive value. And in case if we take the square of this, it would be plus 49. So we have a positive value. Yeah. So now we take the deviation from all of these individual data and sum them up after squaring them, and then we take the average of this, that is, we divide it by the total number of data. Okay, and finally, taking the positive root of this number, we get standard deviation. Now the standard deviation is also called as the root mean square deviation, and it's denoted by the letter sigma. Let's see why it's called root mean square. As I said, we call this as root mean square deviation. Now we see here what we do is we are finding the mean, the arithmetic mean of the deviation. This is the arithmetic mean of the deviation, which is of course squared, so it is the mean of the square of the deviation, and then we take the root over it. So easy to remember, we call this as root mean square deviation. And the symbol, as we have seen, is sigma. Now when we square this value, what we get? When we take the square of sigma, the square root will go away and we simply get summation xi minus x bar square over n, and this quantity is called as the variance. Now this is very often used, and so it's important to mention here that the square of the standard deviation is known as variance. So here we have the formula for individual observation, as we have seen just now, that the standard deviation sigma is equal to the positive square root of the square of the deviation divided by n, that is the positive root of the average of the square of the deviation, the mean of the square of the deviation. Okay, in case if we have frequency distribution, either grouped or ungrouped, in both cases we simply multiply the deviation, the square of the deviation, with the corresponding frequency, and while dividing we take the sum of the frequency. Okay, we also have an alternate formula which is more suitable when the standard deviation is, or when the arithmetic mean, the central tendency value, the arithmetic mean is not a whole number. The above formula which we had seen is more suitable when arithmetic mean is a whole number. And of course we can use both these formula interchangeably for any problem. We will get the answer definitely, but then as far as the convenience and ease is concerned, the second formula which we have here is more suitable when it's not a whole number, when it is a decimal, whereas the first one is more suitable when it is a whole number. How did we get this formula? In fact, this formula is what we have already. It's just a different form. We have the standard deviation as summation xi minus x bar square by n and the positive root of this. The variance would be summation xi minus x bar square over n. Let's see how the second formula is derived from the first one. Now here if we see, we have the square of xi minus x bar, meaning it's to be multiplied with the same value. Therefore, we can write it as summation xi minus x bar multiplied by xi minus x bar. Since it is twice the square, I am writing it the expanded form, and this is divided by n. Further, what I can do is I can split this. Let me take n outside here, and then we have summation of xi, the first term, multiplied by both of this. So we will have xi minus x bar, okay, and then minus 1 by n summation x bar into xi minus x bar. Yeah, I have simply split this into two. First is this xi multiplied by the whole term, the whole second term, and second is this x bar multiplied by the whole second term. Okay, now this could be written as 1 by n summation xi multiplied by xi as xi square, and then minus summation xi into x bar, of course n being the common, minus. Now here, if we look at this, this is a constant. I can pick it up and take it outside the summation sign. Therefore, I will have x bar by n times summation xi minus x bar. Now if you look at this summation xi minus x bar, this is the sum of the deviation from the actual mean. And what do we know about this? Yeah, the sum of the deviation from the actual mean is always equal to 0. So this whole term will be eliminated. Why? Because sum of the deviation from the actual mean, that is the arithmetic mean, is 0. Okay, therefore this whole second term will be eliminated, and we are left just with the first one. So now working further, we will have 1 over n summation xi square, and then here minus 1 over n summation xi into x bar. Again, this x bar is a constant and it can be taken outside the summation. Therefore, we will have 1 over n summation xi square minus x bar by n times summation xi. Okay, now when we take this n here, it will be written further as 1 over n summation xi square minus x bar times summation xi over n. Now what is this summation xi by n? Summation xi over n is nothing but the arithmetic mean. Therefore, we can write this further as 1 over n summation xi square minus x bar multiplied by x bar. This we know, arithmetic mean is equal to x bar. Therefore, we can write x bar square. Therefore, our formula can be written as summation xi square by n minus summation xi by n the whole square, or x bar square. Okay, and this is the formula for individual observations. In case if we have frequency distribution, the formula would be changed appropriately. That is, in places of summation of xi and summation of xi square, we would multiply them with the corresponding frequency values, and it would become summation fi xi square divided by capital N minus summation fi xi by n the whole square. And in case of variance, we'll simply square this term, and so the square root will be taken away, and here we will have the formula in this way. Now if we look carefully at this, the first part of the formula is summation xi square by n, which is simply the mean, because summation xi by n is the mean, but here instead of taking the summation of xi by mean, we are taking summation xi square by n. That is, we are taking the mean of the square of the individual data, not of xi but of xi square. Therefore we can call this as mean of the squares, minus summation xi by n is the mean, so this can be written as the square of the mean. Therefore the formula could be remembered in this way, that it is the mean of the square minus square of the mean. And then we also have shortcut formula, which of course we will take on later on. Today let's understand and consolidate the previous formulas which we have seen, the two previous formula, and let's do some working using a numerical problem. To start with, let's take a problem with raw data. Here we have the weight of the students, of 10 students of a class. These are individual data. Let's find out the standard deviation and the variance of this using first the first formula and then the second formula. Okay, now to use the first formula, what we will have to do is, let's say that these are my individual observations x. I first need to find the arithmetic mean. That is, I'll have to take the sum of these individual data and then divide this sum by the total number of students, that is 10. So this is the sum and then this is the arithmetic mean. Okay, once we have got the arithmetic mean, then we need to find the deviation from the arithmetic mean. Okay, so the deviation is obtained by taking the difference between the value and the arithmetic mean. So for the first data it's minus 6, 45 minus 51 is minus 6, and then we can drag this down to all the other cells by of course fixing the position of the cell containing arithmetic mean. So here we have the deviations from the individual data, and then I need to exactly square them before I could find the average of this. So the square of this would be the value raised to 2. Okay, and this will simply be the value of the previous cell raised to power 2. Same for the whole column. So here we have the square of the deviations, and then we need to find the average of this. Therefore first we will take the sum and the sum is 356. And here remember, I had said that the sum of the deviation from the actual mean will always be 0, and here we have, this is the sum of the deviation from the actual arithmetic mean, which is 0. Okay, the sum of the square is 356, and then I need to take the average of that, which is simply divided by the value here divided by 10. Therefore the value here divided by 10, the total number of students, would give me the variance, of course, because we haven't still found the square root of this. So this is the variance, and standard deviation we can simply find by taking the square root of this data. Okay, so now the standard deviation here is 5.9667. What about the coefficient of standard deviation? Yeah, the coefficient of standard deviation is simply the value of standard deviation divided by the actual arithmetic mean multiplied by 100. So let me do that here. This is the standard deviation divided by the actual mean, and then this ratio is multiplied by 100, and this is our coefficient of standard deviation, also called as coefficient of variation, in short CV. Okay, so let me give that here. Coefficient of standard deviation or coefficient of variation, CV, is simply the standard deviation divided by the arithmetic mean into 100. Okay, so here we have the working. Let me just repeat the working. We have the individual data. What we do first is find the sum of these data and divide by the total number of data. That is, we find the average, the mean, which is 51 in our case here. Then we take the deviation of these individual data from the actual arithmetic mean by subtracting them, and then we square these values here. After we have squared, we sum them up. We sum the square of the deviation from the actual mean, and then we divide that by n, the total number of data. What we get is the variance, and then taking this positive square root of this variance, we get standard deviation. And finally, to find the coefficient of variation, we take the standard deviation, we divide it by the arithmetic mean and multiply it by 100. So here we have, very simple. Let's move on and solve the same question using the second form of the formula. Let's see if we get or not. Of course, as I said, that each one is convenient in certain cases, but we can work and we can see how the formula works. So again, to use the second formula, we need to take, first we need to find the arithmetic mean of these data. So the arithmetic mean is simply the sum divided by the total number of data, which is 51. And then, if you recall, remember I said that the second formula could be easily remembered, that it is the mean of the squares minus square of the mean. I have got the mean here. If I square it, I'll get the second part of the formula, square of means. Yeah, to get the first part, I need to find the mean of squares. So I need to square the individual data. Okay, square of individual data is simply the number here raised to power 2, and here we have, let me drag it down to all the other cells. Yeah, so these are the square of the individual observations. I need to find the mean of this. What I do, I simply take the sum of these and then I divide them by 10. So it is this value divided by 10. I have the mean of mean of the squares. Now to find the standard deviation, let me do that here. First, of course, the variance. Variance would be mean of squares, which is this value, minus square of means. This is my mean, and I need to take the square of this, so this raised to power 2. Yeah, so again we have the same value of variance, which is 35.6. From here, finding standard deviation is simple. We take the square root of this value and then finding the coefficient of variation. Again same, we take this divided by the arithmetic mean and then multiply the whole term by 100. Okay, so we have the coefficient of variation here. Now if you look at this, you see that the numbers here, when we find the squares, are big, and if in case if you have to do it using paper and pen, it would be difficult. There, for those cases, we will use shortcut method, which we shall take up later on. For now, this is the simple working of both the formulas which we had seen, but the working today is confined only to raw data. To take up the cases of grouped and ungrouped frequency distribution, we shall be doing it in the next session. So keep watching edupediaworld.com videos. Thank you.